In this nugget, together we'll apply IPv4 addresses to router interfaces as well as to computers. Let's begin. I'd like you to imagine in your mind that we have come up with an IP addressing scheme as follows. So these networks, these IPv4 networks A, B, C, D, E, F, and G, represent the networks A, B, C, D, E, F, and G. So for networks A through F, we're using a Class A address of 10, which is in the private RFC 1918 private address space. We're using a 16-bit mask on networks A through E, a 24-bit mask up here at the branch office on network F. We're also using a private RFC 1918 address space of 192.168 right here between router 2 and the service provider. Here circled in green are the host IP addresses that I've assigned to the router. So router 1, its IP address ends in .1 on both of its interfaces. And router 2, on its interface going to the firewall, it ends in .2. And the 2/0 interface also has a .2. However, the interface that goes over to the internet service provider, which is on the 192.168.1 network, that has a host address of .253, and our service provider on that same network has an IP address that ends in .1. At our branch office up here across the serial link, they've got a .4 as their host IP address in that last octet. So what I thought would be fun to do is go through the implementation of our IP addressing scheme on actual gear. Now, there's lots of vendors out there who make routers. The primary vendor is Cisco, but there are others such as HP, Juniper, and several others. So as we go through applying the IP addresses on router 1 and router 2, I'd love for you to focus on the concept of what we're doing. We're applying IP addresses to router interfaces. The actual syntax will vary from vendor to vendor depending on whose router, which vendor's router we're configuring. Also, for our discussion, let's say the firewall is already pre-configured and it's using .100 on all of its interfaces. The one that goes to router 1, the interface that goes up here to the switch, and the interface that goes over to the right to router 2. So the firewall team has already configured the firewall. Our job is to configure router 1, router 2. There's also a branch router out here. And while we're at it, let's also configure one of our computers that's on the internal network. And instead of using DHCP, let's use static configuration to configure its IP address, its mask, its default gateway, and the DNS server that this PC is going to use. And for our demonstration, let's say the default gateway is going to be the IP address here on router 1, which is 10.1.0.1. The mask is going to be 16 bits in length, which we represent in dotted decimal, so that'll be 255.255.0.0. And the DNS server we'll tell computer 2 to use is, let's use one of Google's out on the internet at 8.8.8.8. Now you might ask, well, how in the world is this computer going to get to a DNS server that's way out here on the internet? The answer is it will use its default gateway. So as long as the default gateway is configured correctly and router 1 has reachability out to the internet, that DNS request from computer 2 should be able to be forwarded all the way out to the internet, including going through the process of network address translation, which we talked about in our nugget on NAT, that will swap out the private IP address that computer 2 is using for a globally routable address as a packet gets forwarded out to the internet. We're going to begin our configuration right here at router number 1, which I've affectionately named R1. And this happens to be a Cisco iOS router. And to get into what's called configuration mode, to make changes to the router configuration, we type in the command configure space terminal. If you're watching somebody else configure this live, they might just type in config space T, which is a shortcut for the command configure space terminal. It basically means we want to configure this router from the terminal that we're currently connected on. Next, because a router has lots of different areas that we could configure, we need to go specifically to the area that we want to configure, and that's interface 3/0. And to do that, we would simply type in the command interface space Ethernet 3/0 and press enter. And that takes us logically into this area, this room, if you will, for the configuration parameters for that specific interface. And on some devices, even if they say the word Ethernet, sometimes it may be fast Ethernet or gigabit Ethernet. And when talking about gigabit versus fast Ethernet versus Ethernet, it's all about speeds. It really is the same technology, but just done at different speeds. Now, sitting here in interface configuration mode for interface 3/0 on router 1, to give it the IP address that we planned on. And to be clear, the IP address that we want to assign to this interface is 10.1.0.1 with a 16-bit mask. What we're going to do is we're going to type in the command IP space address, put in the IP address space, and then the mask in dotted decimal. So here in interface configuration mode, that would look like this. IP address 10.1.0.1 space 255.255.0.0, which represents the first 16 bits of the IP address is being used for the network, and the last two octets, the last two numbers, are being used for host addressing. And if you need any refreshers on IPv4 addressing or subnetting, I would have you refer back to our IPv4 subnetting course to brush up, if needed, on any aspects regarding IPv4 or IPv4 subnetting. The other thing we're going to do here on this interface is we are going to bring it up with the command no shutdown. By default, the interfaces on a Cisco router are shut down by default, so the no shutdown brings them up. And then we're going to type in exit, and that's going to exit us out of that interface configuration area on this router. And we're now back in an area called global configuration. However, we have another interface to configure. That's this guy right here, interface 3/1, and it's going to have the IP address of .1 on network B, which is 10.2.0.0. That's the network /16. So to do that, we'll go into that specific interface, interface Ethernet 3/1. We'll use the command IP space address of 10.2.0.1. And then we'll put a 16-bit mask in dotted decimal, and then we'll do a no shutdown there as well. And if we're completely done with configuration, we could go ahead and type in end, and that will take us out of configuration mode back to what's called privileged mode here at the command line interface, the CLI of this Cisco IOS router. Next, let's make a road trip over to router 2. Again, we'll presume for this discussion that the firewall has already been configured for us, and let's go to router 2. So here on router 2, we'll go into configuration mode. We'll go further into interface Ethernet 3/1 and give it the IP address 10.4.0.2 with a 16-bit mask. Now also on this router 2, it is also performing network address translation. And although there are quite a few commands to implement it, one of those commands on a Cisco router is the command IPNAT on the interface. And that simply identifies this interface, if we use the IPNet inside command, as an inside interface from the perspective of NAT. And over here on interface 3/2, we could use the command IPNet outside. And that indicates to NAT that this interface is an outside interface. So if there's a rule in place that says, okay, traffic coming from the inside that's going to the outside, as long as it matches certain parameters, let's go ahead and do network address translation. These IPNet inside and IPNet outside commands allow the router to know which interfaces are inside and which interfaces are outside. So here in interface config for 3/1 on router 2, I'm going to use the command IPNet inside. We'll bring the interface up with the command no shutdown, and then we'll exit interface configuration mode. Next, let's go to interface 3/2. This is the interface connecting R2 over to the internet service provider. So we'll go into interface config for Ethernet 3/2. We'll give it the IP address of 192.168.1.253 with a 24-bit mask, we'll use the command IPNet outside. We'll bring it up with a no shutdown, and then we'll exit interface configuration mode. And we're not focused on memorizing syntax. We are focusing on the concept of applying IP addresses to the interfaces of a layer 3 router. In our example, it's a Cisco IOS router. Next, we have this interface right here. This is serial 2/0 that's connecting to our service provider for a wide area network connection up over to our branch office. And that is network E, and network E is the 10.5.0.0/16 network. The IP address we're going to have on R2 is .2 as the host ID. So here from global configuration, we'll go into interface serial 2/0. We'll give it the IP address of 10.5.0.2 with a 16-bit mask, which is spelled 255.255.0.0. We'll say IPNet inside. We'll do a no shut. We'll type in exit, and we'll end to get out of configuration mode. Now you might ask, well, Keith, how come this is an IPNet inside interface? And the reason for that is if users up here at the branch network, if they're forwarding traffic over this WAN link, and that's how they get out to the internet, because they're also using private RFC 1918 addresses, as router 2 forwards that traffic out to the internet, from a NAT perspective, the router 2 needs to make sure it does the translation of the source addresses before routing the branch's traffic out to the internet. And that's why we added the IPNet inside command here as well on serial 2/0. And then last but not least, we need to configure the branch router. So let's go to the branch router. So here at the branch router, we'll go into configuration mode. We'll go into interface serial 2/1 because that's the interface it's using to connect over the WAN network. We'll give it the IP address of 10.5.0.4 with a 16-bit mask based on our plan, and we'll bring it up with a no shutdown command. Now last, but certainly not least, let's go over to computer 2. And we could use a DHCP service. For example, we could make computer 2 a DHCP client, assuming that there's a DHCP service running somewhere in this network. Or we could manually configure the details for the IP address, the mask, the default gateway, and DNS. So let's do that. Let's use .190 as the host ID for computer 2 on the 10.1.00/16 network. For the default gateway, we'll point to .1 on that same network. For the mask, we'll indicate it's a 16-bit network, which is 255.255 in dotted decimal. And we'll tell this computer to use 8.8.8.8 as its DNS server. So here at PC1, let's go to our control panel. There's lots of ways of getting there. We could go to the Windows main page, type in control to get there. Or we could right click on our network interface card and go to properties. That would get us there as well. So let's scroll down a little bit and go down to network. Here's network and sharing center. That looks great. There's change adapter settings. Here's our Ethernet 0 interface on this Windows computer. We'll right click, we'll go to properties of that interface, and we'll scroll down to TCP/IP version 4. And from here, we could double click or we could click on properties. And instead of using DHCP, we want to go ahead and statically configure this, and we'll specify the IP address as 10.1, which is the network we're on. And our host ID is going to be 0.190. Based on what? Based on our plan that we just created a few moments ago to identify what IP address we're going to use on this computer. We'll hit tab. And you'll notice when I hit tab, it automatically wants me to use 255.0.0.0. And that's because it knows this is a Class A address. And by default, the default mask for a Class A address is just that first octet. However, we are doing custom subnetting, and we're using a 16-bit mask, so we'll put 255 for that second octet of the mask to indicate that our network address is 16 bits long. Our default gateway is at 10.1.0.1. We just configured that a few moments ago. And then we'll specify that the DNS server that we want to use is 8.8.8.8, which is a Google DNS server. and we'll click on OK. Then we'll click on Close. And let's go to a command prompt just for a moment and verify our configuration with an ipconfig. So by typing in ipconfig, it shows us our IP address, the mask length, which we put in, and our default gateway at 10.1.0.1. If we want to see more detail, we could use ipconfig space /all, and that would show us additional information, including our layer 2 MAC address, whether or not we are a DHCP client at this moment or not, because we manually configured the details. There's our IPv4 address, our default gateway, and there's the DNS server that we configured as well. So from a troubleshooting perspective, what we could do is if we wanted to verify basic connectivity, we should be able to ping the IP address of our default gateway because it should be a local IP address on our same IP subnet. So if we type in ping and type in 10.1.0.1, press enter, sure enough, we have 4 replies out of 4 coming back from our default gateway. That's R1 who's responding to us. So if we did a ping out to 8.8.8.8, which is our DNS server, which is on the internet, we'll press enter, and it's coming back saying destination host unreachable. What possibly could be the problem? Well, let's take a look at our topology together to identify what the problem is. So here in the verify stages, we configured IP addresses on the router interfaces. We configured an IP address on computer 2. We verified that computer 2 could ping its default gateway at 10.1.0.1. However, when computer 2 tried to access an internet resource like 8.8.8.8, it was not successful. And my friend, on a new network, here's the reason why. These routers do not know diddly squat besides what they are directly connected to. Router 1 knows about the 10.1 network because it is directly connected to that network. Router 1 also knows about the 10.2 network because it is directly connected to that network. However, what Router 1 does not know is anything beyond those directly connected networks. It doesn't know how to get to network C or network E or network G or anything on the internet because we have not implemented any type of routing yet as far as training the routers on how to forward traffic. And that, my friend, is the topic for our very next nugget. So in this nugget, we identified how to apply IP addresses based on a plan to our router interfaces, verify connectivity between a computer and a router on the same subnet, and as I mentioned, in our next nugget on routing, we'll take a look on training the routers on how to make intelligent forwarding decisions based on layer 3 information it sees in each packet that it receives. I appreciate you joining me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.